morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about Direct Memory Access. Direct Memory Access is a DMA controller and it is a hardware device that allows input-output devices to directly access memory with less participation of the processor. Direct memory access is a method that allows an input-output device to send or receive data directly to or from the main memory by passing the CPU to speed up memory operations. The transfer of data between a fast storage device such as magnetic disk and memory is often limited by the speed of the CPU. Removing the CPU from the path and letting the peripheral devices manage the memory buses directly would improve the speed of transfer. This transfer technique is called direct memory access. So, first of all, we are going for the direct memory access. So, what is the DMA and how it is helpful to the CPU or computer? So, DMA is a controller and it is a hardware device that allows input-output devices to directly access memory with less participation of the processor. So, suppose if I am taking one CPU, we are connecting input and outputs. For the CPU, we need a memory. Without memory, we can't do anything. So, CPU is interconnected with memory. So, suppose I have so many inputs and so many outputs are there. So, when I am going for the ALU, Arithmetic Logic Unit, I need to do ALU process. So, definitely we need the help of CPU. Suppose no ALU process. So I don't want any ALU. So without ALU means arithmetic logic unit, I no need of any arithmetic logic unit. So only simple I have to connect input and output. I don't have to go for ALU. Any ALU works. So not a programming work. So there is no programming. No programming means no need of CPU. Okay. So only I need input, output, CPU with memory. So for unnecessary operations of without ALU, suppose ALU means I need CPU. Without ALU means unnecessary of ALU help. Without help of any, suppose I am going for the programming, definitely we need ALU. Suppose I don't have any ALU means I don't have any programming language to execute that one. So I no need of ALU. So if I no need of ALU means there is no need of connected to CPU. Why? Because unnecessarily we are connecting all the inputs of without ALU means connected to CPU. CPU will be more burden and lifetime will be decreasing. So it will be burden means the unnecessary programming will be doing the one. So burden will be there. So lifetime of the CPU will be decreased. So that is the reason we are connecting DMA, direct memory access. That means only memory and DMA will be connected. No need of any CPU. I no need of any CPU. Directly input DMA with memory. Direct memory access. Input output with memory. Direct memory access without need of any CPU. So that is the reason we are less burden on CPU and the lifetime of the CPU will be increased and the time will be consuming for this process. So that is the reason we are connecting DMA with memory without the help of CPU. So it is a hardware device that allows input-output devices to directly access memory with less participation of the processor. Direct memory access is a method that allows an input-output device to send or receive data directly to or from the main memory by passing the CPU to speed up memory operations. The transfer of data between a fast storage device such as magnetic disk and memory is often limited by the speed of the CPU. Removing the CPU from the path and letting the peripheral device manage the memory buses directly would improve the speed of transfer. This transfer technique is called DMA. So when DMA is allows input and output device to send or receive directly. What is the data? The data will be transferred through input to output with the help of DMA and main memory. So DMA with memory we need. So memory is internally connected to this one, and by passing the CPU to speed up memory operations. So without a CPU, we are passing the information with speed up, and the transfer data between the fast storage device, such as in the help of memory, I am taking magnetic disk. So it is also one type of memory, and memory is often limited by speed of the CPU. So if I am connecting the CPU with memory, if I am using magnetic disk, it is lots of time to transfer the data from input to output. And if you are removing the CPU from the path and peripheral devices, means input, output and magnetic disk. So only input output direct to memory access will connecting to the magnetic disk without no CPU help. There is no CPU help. So it is called that the speed of the transfer will be increasing with peripheral devices and magnetic disk with DMA input output without help of CPU. So during DMA transfer, the CPU is idle and has no control of the memory. So when the DMA is transferring the data, then no control of the memory buses. There is no need of any buses of control. Why? Because there is no CPU, means no need of any buses. Directly the data will be transferred from input to output. There is no address bus, data bus, control bus like this, and no control of the memory. Why? Because without CPU we can't perform any buses. No CPU means no buses, and manage the transfer directly between the input output devices and memory. So the CPU may be placed in an idle state in a variety of ways. One common method extensively used in microprocessors is to disable the buses through special control signals. So bus request and bus grant. So what is a bus request? First we are going for the CPU may be placed in idle state in a variety of ways. Suppose the CPU is connected. One common method extensively used in microprocessor is to disable the buses through special control signals. If CPU is idle state, then buses should be disabled through special control signals. So the bus request input is used by the DMA controller to request the CPU to seize control of the buses. When the bus request should become, means the CPU is enabled. If there is no CPU, means no buses are there. But bus request input is used by the DMA controller to request the CPU to seize the control of the buses. Any bus control is requested to the CPU, then DMA controller is requesting the CPU to control the buses. There is no need of buses to control all the buses. And the CPU activates the bus grant output to inform the external DMA that buses are in the high impedance state. So when the CPU is not in idle state, CPU is activate, then bus grant. There is no activate, means no buses. If the CPU will activate, then bus grant output to inform the external DMA that the buses are in the high impedance state. So why? Because CPU is activated, then bus grant will be accepted, then high impedance will be state. So if there is no DMA is not activated, then is no buses should be passed and there is no high impedances will be there in the state. So suppose here I am taking one CPU, here bus request, bus grant. So bus request means we are requesting to the CPU to accept the buses. Bus grant means CPU will give the information to the input output other peripherals to getting the bus grant. We are granting the buses. Okay. And here what are the outputs are there? Address bus, read, write. So what is the read operation? CPU to user. And what is the write operation? User to CPU. So DBUS means data bus, address bus, read, write, and it is a CPU bus request, bus grant. So when high impedance is disabled, when BG is enabled. So if I am going for the BG is enabled, high impedance, CPU activates the bus grant output to inform the external DMA that the buses are in the high impedance. So when it is a high impedance of this one, then bus grant is enabled. If high impedance is disabled, then I no need of any bus grant for this one. Okay. So the CPU may be placed in a idle state in a variety of ways, and a common method extensively used in microprocessor is to disable the buses through special control signals. When we are disable the buses through special control signals, then no need of CPU. Suppose if we are enable the bus request, then bus grant will be accepted from the CPU, then CPU may be activated. It will be not in the disable mode. When it will be disable mode means we are disabling the buses through a special control signals. And DMA transfer, direct to memory access transferred. How? The position of the DMA controller among the other components in a computer system is illustrated in the following figure. We can see this, we can understand easily. The DMA position of the controller, other components in a computer system is following. Suppose here I am taking CPU, RAM means I'm connecting one memory. So DMA and input output peripherals. So first of all the inputs, that means interrupt, bus grant, bus request, connected to CPU, and these are interconnected to the memory, read, write, data bus, address bus. So these are connected to CPU to memory. So CPU to DMA is enabled through these lines. So DMA is connected with input output peripherals. So input output will give the DMA acknowledgement and DMA request. DMA acknowledgement is for DMA to input output. DMA acknowledgement means it will accepting the input output request data, and DMA request means the input and output data is passing through the DMA. So CPU will get the information from input output to DMA, DMA to CPU and memory, and will get the output like this. But suppose if I am no need of CPU, if CPU disabled means this will be disabled. So what are the lines are where we are disabled? So directly we are giving the information to the, without CPU we are giving directly information to the data bus, address bus and read and write. So this should be disabled. So what will happen now? Through the address bus, data, write, read and address. So it will not go to the CPU, directly DMA to memory, DMA to all are connected to the DMA to memory, and this DMA input output peripherals. Input output peripherals. So input output is connected to the DMA and DMA is connected to the memory. Again memory to DMA, DMA to output. So one input is entering to the DMA, DMA will take the help from memory and is then related to this input. Then DMA is giving the acknowledgement to the output. Then output will be getting. So input output to DMA and memory. It is DMA controller. But here CPU is connected, means we are not disabled, the CPU is enabled. So CPU is enabled means CPU is connected to the DMA and DMA is connected to input output and the CPU is connected to the memory. So it is a long process. So when I need to disable means if there is no arithmetic logic operations, I no need of any arithmetic logic operations, then CPU will be disabled. Then if CPU disable means no need of any interrupt, no need of bus grant, no need of bus request. So all are should be disabled. Only DMA, memory, input output. There is no interrupt, no bus grant, no bus request. Only DMA through memory. What is that means? Read, write, address, data, and connected to the memory, RAM or ROM, and input outputs are connected to DMA through DMA acknowledgement and DMA request. DMA to memory, it is connected to input output peripheral devices. So DMA to input output peripheral devices and DMA, it is connected to the memory. So if I need a CPU means definitely we will connect through CPU, and this CPU is connected to memory. I no need of any memory directly. So directly it is connected to CPU. So CPU will give interrupt and will give the address, data like this, and read, write. So suppose I no need of any bus grant. So here no need of any bus grant, bus request. Bus grant, bus request. So if it is disabled means no interrupt, no bus grant, no bus request. Okay, DMA to memory. No need of any CPU like this. Okay, it is a process of CPU connected to DMA and the CPU without connection of DMA. Okay, it is a DMA, direct to memory access control. And the following figure shows the block diagram of a typical DMA controller communicates with the CPU through data bus and control lines. So address bus is there. It is the address bus with address bus buffering and data bus buffer. So what is this means? Totally we are connecting the DMA to the CPU. So it is a DMA request, input output device. Input output device is the DMA request and the DMA acknowledgement. So what are the inputs and outputs to the DMA means? DMA selection, direct to memory access, and register selection. So DS and RS are the inputs, and read write operations already we know that these are definitely we need. If CPU is connected, then read and write connected to the CPU, and bus request, bus grant, and interrupt. So these are connected to the DMA, and it is a control logic. So it is connected to the control register, word register, address register, and address buffer. So it is the address buffer means address bus is connected to the address, and data bus means data buffer. So address bus, data bus, and all should be controlling. It is about the control bus. So internal buses, address, data, and control register means control bus. So we are interconnections. What are the interconnections means? Input output is connected to the CPU or DMA with the DMA request and DMA acknowledgement. So what are the inputs to the DMA means? DMA selection, register select. DMA select means I have to select the DMA. If I am not selecting means CPU will be connected to this. And register selection, read, write, bus request, bus grant, and interrupt. So when we need, if the CPU is there, then we need all those things. If there is no need of CPU means bus register, bus request, bus grant, and interrupt are disabled. So it is about the direct to memory access with CPU and without CPU. And DMA controller registers, the DMA controller has 3 registers as follows: address register, word count, control register. So what is the each one we discuss now. So DMA controller registers. So first one, address register. It contains the address to specify the desired location in memory or starting address of the memory. So address register contains the address to specify the desired location in memory or starting address of the memory. So where is the address? Where is the location of memory? So address is nothing but it is an interconnection to the memory to input output through DMA. So to specify the desired location in the memory. So in the memory means it is a lot of memory is there. Where is the exact location we need in the memory? So that is the address of the memory. Word count register. It contains the number of words to be transferred. So I have to transfer the data from through transmitter to receiver. How much length of that word? So it will be containing the number of words or what is the length of the data. Words means data quantity. Data quantity to be transferred. How much data I have to transfer from transmitter to receiver. And the control register. It specifies the transfer mode, whether it is read or write. Control register means it specifies the transfer mode, whether is it read or write. Read or write. It will be control register means controlling the read and write operations. Okay. So address register means in the memory what is the specific location I need, that is the address register. And after finding out the address, what is the data and what is the quantity of the data. So the data in the form of words to be transferred. And I got address and I got data. So address is there, and the data is there. So what is next? We have to control the data through the bus. So control register to specify the transfer mode, whether it is read or write mode in that. That is a DMA controller registers. So in the explanation part, what is about the DMA? The CPU initializing the DMA by sending the given information through the data bus. So CPU to DMA. What is the data is transferred? The CPU initializing the DMA by sending the given information through the data bus. So CPU through DMA, we are passing the data through CPU to DMA. So through the data bus will passing the data from CPU to DMA. And the starting address of the memory block where the data is available or to read or where data are to be stored or to write. So the starting address of the memory block. Suppose we have the memory. So shall we need an address for this memory? Yes, we need address location to find out the memory. So the selection address of the memory block where the data is available to read or where data are to be stored or to write. So for this memory, I need, are you performing read operation or write operation through the memory? That is a address selection through address. And it also sends word count, which is the number of words in the memory block to be read or write. So are you reading or writing? Yes, I am reading or writing. So through the memory, what is the word length? So what is the address or data? So this data in the form of word transferred and with memory suitable to the memory. To control to define the mode, the transfer such as read or write. Control to define the mode of transfer such as read or write. A control to begin the DMA transfer. So when the DMA controller is enabled, then read or write operation through the address bus and data bus with word count. And the CPU communicates with the DMA through the address and data buses as with any interface unit. The DMA has its own address which activates the DS and RS lines. Okay, so already we discussed here what is the DS and RS. DS and RS. So data bus and register. So this data and RS lines of the CPU communicates the DMA through the address and data. Address data. Address bus and data bus. And interfacing unit, the DMA has its own address which activates the DS and RS lines. Okay, and the CPU initializes the DMA through the data bus once the DMA receives the start control command, and it can start the transfer between the peripheral device and the memory. So when the DMA is received or DMA is enabled, initialized, so CPU initializing the DMA. So DMA is enabled through the data bus, and DMA receives the start control command, and it can start the transfer between the peripheral devices and the memory. So the data will be transferred through the peripheral devices and the memory. Peripheral means input output to memory. The data is passing through the input output to the memory through the data or word count. And when the peripheral devices sends a DMA request, the DMA controller activates the BR line informing the CPU to release the buses. The CPU responds with its PG line informing the DMA that the buses are disabled. When the DMA is activated, direct to memory access, then all the buses are disabled. When the CPU is enabled, all the buses are should be enabled through the bus grant and bus request. And the DMA puts the current value of its address register into the address bus, initiates the read or write signal, and sends a DMA acknowledgement to the peripheral devices. And read and write lines of DMA controller are bidirectional. This bidirectional of transfer depends on the status of the BG line. So bus grant equal to 0. What will happen? When I am going for the data is in the form of read and write operation. So it is about the data. The data is in the read mode or write mode. Okay. So the DMA controller is a bidirectional. This data is in the read or write. The DMA is enabled. If BG bus grant equal to 0 means there is no bus grant, then read and write are input lines, and CPU to communicate with the internal DMA register. So there is no bus means no need of any CPU. Then CPU communicate with the internal DMA. Then no buses means DMA enabled. It is directly enabled. If bus grant equal to 1 means buses are enabled, then output should be enabled with the DMA controller to the random access memory to specify the read and operation for the data. So the DMA is enabled means bus grant is enabled, then output lines are enabled, and read or write operation of the data should be specified in the memory. What is the memory? Here I am taking as a random access memory. So DMA is connected through the DS, RS and bus grant and bus request through the CPU, read, write, address and data with interrupt, bus grant and bus request. So these are internally connected to the RAM through the read control, write control, data bus and address bus. So these are the internally connected through the input output to DMA, DMA to CPU and CPU to memory. So these are internally connected. And where the peripheral device receives a DMA acknowledge, it puts a word in the data bus or write, or receives a word from the data bus for read Thus the DMA controllers read or write operations and supplies the address for the memory. The peripheral unit can then communicate with memory through the data bus for direct transfer between the two units with the CPU is momentarily disabled. So each word transferred of the DMA increments its address register, decrements its word count. If the word count does not reach 0, the DMA checks the request for coming from the peripherals. So DMA connected to the memory. The peripheral unit communicate with input and output through the data. The data will be passing through this one, and the transferring of two units with the CPU is momentarily disabled. For each word that is transferred, the DMA increment its address register. DMA will incrementing its address register. Address is incrementing means decrements its word count. So address is incrementing means data count will be decrement. If the word count does not reach 0, word count does not 0 means it is in incrementing mode, then DMA checks the request line coming from the peripheral. If word count is not 0, then DMA is enabled and it is requested coming from the peripherals. Then it is requesting the input to output when word count is not 0. And when a high-speed device line will be activated as soon as the previous transfer is complete, a second transfer is then initiated and the process continues until the entire block is transferred. When the high-speed device is connected to the CPU, then we no need of any primary memory. Then second transfer of the initiated and the process will be continue. And when the peripheral speed is lower, peripheral means inputs and outputs are connected to the CPU or to the DMA, then the DMA request line may come somewhat later, and this DMA is disabled to the bus request into this, and the CPU can continue executes its program. When the peripheral request a transfer, the DMA request the buses again. The word count register reaches 0. Here no 0 means DMA is connected to input output, but here word count reaches the 0 means DMA stops the transferring the data from input to output. It will stop the data from input to output when word count will be 0. If word count is not 0 means the data will be transferred from input to output. When the CPU responds to the interrupt, it reads the content of the word count register. The 0 value of the register indicates that all the words were transferred successfully. The CPU can read this register at any time to check the number of words already transferred. When the CPU is enabled and it is response to the interrupt, means interrupt is enabled, then what will happen? The word count will be increasing successfully and it will be transferring through input to output. And if DMA controller is enabled without a CPU, so each channel has a request and acknowledge pair of control signals which are connected to separate peripheral devices. Each channel also has its own address register and word count register with a DMA controller. So these are the references. So we have discussed today about DMA. So it is a DMA connected to the input outputs without a CPU. It is a bus request, bus current to the CPU. It is a CPU, DMA, memory, input outputs are connected. If CPU is disabled means DMA, memory access, input outputs only connected. So it is internally connected to the CPU enabled or CPU disabled with DMA. It is a DMA controller with 3 registers: address register, word count and control register. And it is about the exploitation of the CPU with DMA enabled, and it is a read write operation of the DMA with bus grant equal to 0 and bus grant equal to 1, and it is a DMA acknowledgement when word count is 0 or non-zero. It is a peripheral is slower and high speed devices, and the CPU response to the interrupt is enabled, and CPU is disabled and DMA control is enabled. So what is the data transfer? Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.